Okay, this is a ray tracing example where now we have an image. So it says here the image is located 12 millimeters to the right of a 4 millimeter focal length converging lens. So let's just note that it's a converging lens with our arrows. By the way, a diverging lens would look like this, would do like the tips like that. We may need that space. Okay, and we're going to put our focal length here, 1, 2, 3, 4. 1, 2, 3, 4. We're going to place our image. This is 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to make this pretty tall. Like that. And now I'm just going to start, right? So this is an image. So I just want to remind myself this is an image. It's to the right, right? So I need to find the object distance using a ray tracing diagram. So what I'm going to do is I'm just going to start. I'm going to imagine I exit my lens. This would be an exit ray parallel to the axis, so that means it must have gone through the focal point. And so that means we're going to go through here like that. It's going through the focal point here on this side, on the image side. And then it comes out over here like this. And then finally, it's going through the center of the lens. Like that. And so my image is going to be located here. And so, or my object, so this is my object. And let's see what our graph tells us. So if we want to calculate our object, let's do our object distance. Calculate if our image distance is di is equal to 12 millimeters, our object distance d0 is equal to 1, 2, 3, 4, 5, 6, 7 is equal to 7 millimeters. Our object height of the object is equal to 1, 2, like 2.5. We notice that our object is inverted. So our object is actually a negative 2.5. So that tells me then my magnification, I can either do di over d0. Or I can do I can do hi over h0. And so I say, okay, my h is I always do it relative to my object. So in this case, my object is, I'm going to call that up, that's erect. So I'm going to say that that's equal to 2.5. And so my image then is going to be a negative 4. And so I can calculate my magnification from that. And my magnification is going to be a negative 1.6. Okay, and so now if I want to do it by calculation, I'm going to say 1 over d0 plus 1 over di is equal to 1 over f. And remember, I started with my image was at 12, so I'm actually now solving for my object. So 1 over d0 is equal to 1 over f minus 1 over di, which is equal to 1 over 4 minus 1 over 12. Now I need to find a common denominator. So in order to, I'll use a common denominator of 12. And for 4 to go to 12, I need to multiply top and bottom by 3. So 3 minus 1, which gives me 2 over 12. And that gives me 1 over 6. So my setting d0 equal to 1 over 6 to equal to 6. So d0 is equal to 6 millimeters. And I compare that here. d0 is equal to 7. So I was pretty not very good with my lines here, right? A ruler would help me to do a lot better, but they're pretty close. So my ray tracing wasn't too bad. If I want to do my magnification is equal to a negative di over d0, and that's equal to a negative 12 over 6. So my magnification is equal to a negative 2. That makes sense because my object and my image is inverted with respect to my object. And then if I want to calculate h0, the height of my object, that's going to equal, so my magnification is equal to hi over h0. So h0 then is going to equal, cross multiply and then divide, is going to equal hi over m. So I'm going to have hi is 4, a negative 4, and then my magnification is a -2, so I'm going to get my h0 is 2. And so remember, I'm saying that makes sense, though, because my height of my object is always positive, and then that tells me the height of my image is a -4 because it's inverted with respect to my object. So that tells me that my height of my object is equal to 2 millimeters. So they're pretty similar. My drawing wasn't the best on that one, so that's what gives me the some of the error in my answers.